Welcome to Understand the Math. In this video, I'm going to go over a lot of examples and show you how to evaluate inverse sine, inverse cosine, and inverse tangent functions. Before you begin, be sure to check out the video description below for a link to free guided notes that you can download and fill in as you watch this video. We'll start with some inverse sine function example problems. When we evaluate an arcsine or inverse sine function, we need to think of it as an angle theta. We'll set arcsine or inverse sine equal to theta. We need to remember that the arcsine function is defined for values between -1 and 1 and is equal to an angle between -pi/2 and pi/2. We can see that in our graph and on our unit circle. So we'll write that the range is between -pi/2 for our angle theta and pi/2. This angle is going to be located in the first quadrant or in the fourth quadrant. For example, theta could be equal to pi/6 and look like this. Before we go on, let's remind ourselves what the values of sine and cosine are for the angles of pi/6, pi/4, and pi/3. For pi/6, cosine is equal to x, and it's equal to √3/2. Sine is equal to y, and it's 1/2. For pi/4, we have √2/2 and √2/2. And then for pi/3, we have 1/2 for cosine and √3/2 for sine. For our first example, let's evaluate arcsine of √3/2. We first notice that √3/2 is in the domain of arcsine, so it's defined and we can evaluate it. We'll say that -1 is less than or equal to √3/2 is less than or equal to 1, and therefore our arcsine is defined. We'll let theta be equal to arcsine of √3/2, and we'll remind ourselves that we need to choose theta to be between -pi/2 and pi/2. We'll take the sine of both sides, so the sine of theta is the sine of arcsine of √3/2. Since the arcsine is defined for √3/2, this expression is just equal to √3/2. When sine theta is equal to √3/2, theta is going to be equal to pi/3. So arcsine of √3/2 is equal to pi/3. For our second example, we'll evaluate the inverse sine of -1/2. Let's note that -1/2 falls between -1 and 1, so this function is defined. We'll then let theta be inverse sine of -1/2 and remind ourselves to choose an angle between -pi/2 and pi/2. So this gives us sine theta is equal to -1/2. Since theta is negative, it's going to lie in the fourth quadrant, and it's going to be equal to -pi/6. So our inverse sine of -1/2 is equal to -pi/6. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. In our last inverse sine example, we'll evaluate the inverse sine of 2. We'll note that 2 is not in the interval from -1 to 1. So this tells us that inverse sine of 2 is undefined. Let's now look at some inverse cosine example problems. We'll think of arccosine x or inverse cosine x as an angle theta, and we'll set arccosine x or inverse cosine x equal to theta. Arccosine is defined for values between -1 and 1, and is equal to an angle between 0 and pi. And we can note that both on our graph and on our unit circle. Our range then is going to be values between 0 and pi, and it's going to be located in quadrant 1 or quadrant 2. To evaluate arccosine of minus root 2 over 2, we notice that minus root 2 over 2 lies between -1 and 1, so the function's defined. We'll let theta be arccosine of minus root 2 over 2. So that means that cosine theta is equal to minus root 2 over 2. Cosine is negative, so it's going to be in the second quadrant, and our theta is going to be 3 pi over 4. This tells us that arccosine of minus root 2 over 2 is equal to 3 pi over 4. To evaluate inverse cosine of 1, we make a note that 1 definitely is between -1 and 1, so the function's defined. We'll let theta be inverse cosine of 1, so that tells us that cosine theta is equal to 1, and that means that theta is equal to 0. So our inverse cosine of 1 is equal to 0. The last inverse cosine example we'll evaluate is inverse cosine of -3. We'll make a note that -3 is not in the interval from -1 to 1, so that tells us that inverse cosine of -3 is undefined. Let's now look at some inverse tangent example problems. Just like we did for inverse sine and inverse cosine, we'll think of arctan or inverse tan as an angle theta, and we'll set arctan or inverse tan equal to theta. Arctan is going to be defined for values between -infinity and infinity, so for all values of x, and it's equal to an angle between -pi over 2 and pi over 2. So our range is between -pi over 2 and the angle can be in quadrant 1 or in quadrant 4. Let's evaluate inverse tan of root 3. We don't need to check if this function is defined because inverse tangent is defined for all values of x. So we'll go right to letting theta equal inverse tan of root 3. That gives us tangent theta is equal to root 3. And we'll remind ourselves that we're going to choose a value of theta between -pi over 2 and pi over 2. Since it's hard to remember angles that make tangent equal to root 3, let's write tangent as sine over cosine. And we'll set root 3 to be equal to root 3 over 2 on top and 1/2 on the bottom. So looking at this, we can see that theta is going to be equal to pi over 3. So our inverse tan of root 3 is equal to pi over 3. For our last example, we'll evaluate the inverse tan of -1. We'll begin by letting theta equal inverse tan of -1 and remind ourselves again that our theta has to lie between -pi/2 and pi/2. So this means that tangent theta is equal to -1. Tangent is negative, so it's going to be in the fourth quadrant, and that gives theta is equal to -pi/4. So our inverse tan of -1 is equal to -pi/4. In the next video in this series, I'll talk about how to evaluate compositions of trigonometric functions.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.